CLion, a cross-platform IDE for C and C++. Download now.
Welcome everybody to my talk on software engineering completeness. My name is Peter Muldoon. I work in Bloomberg. So just a little about me before we start. Very quickly, I started using C++ professionally in 1991. So that's back when there was no standards, no STL, no nothing. Basically, we had to roll everything ourselves. In my professional career, I've tended to do the early part of my career was a lot of consultants. So I did about 21 years of consultant work. That just meant I went to a lot of companies, seen a lot of different ways of doing things and what worked and what seemed to not work very well. And I've been about 12, 13 years in Bloomberg. And right now I work in the ticker plant, which is where we take all the information for exchanges around the world and put them into tickers or for applications to use. So when I go to a conference, what do I like to do? Well, I like to talk on software engineering based in the real world. It's mostly where I code, not in the ivory tower. And I'm hoping that you either take something away or you have a change in how you view things. So you get a different perspective on something. So you come away from something from the talk. And this talk is, earlier in my career, I got asked a lot, are we done yet, by my manager or TL? And what it really meant was, are you done yet? All right, and later in my career, I'm more asking other people, are you done? Right, and the answer usually is probably not, even if they're telling me they are done, right? But why is that, right? Why do we have this problem with, I thought this was done? So what does done mean? The first thing I'm going to do is go to the dictionary and say, what does the dictionary say? Well, it says you bring something up to a required state of completion. All right, so that's how, what does it mean for engineering terms? What does done mean? Well, when I look around at teams, I don't see it written down anywhere. It's kind of just tribally accepted. We somehow know what done means, but I can find done in the Scrum. And there's this thing about the state of the increment, meets quality measures and formal description of equality standards. I don't think most developers keep this in their head when I'm asking them when it's done, right? It's kind of bit more of gobbledygook. But why bother? I mean, surely we can just say, yeah, it's done, and here you go. Like, why bother doing this? All right, well, getting a definition of done, if you do it even locally within your team, right, you get a shared understanding or a unified language of what it means, right? All that tribal knowledge people have access to, it's explicit, and new people coming into your team can also access that knowledge, all right? Now, in the broader sense, right, having a definition of done in your whole organization acknowledges that we have a shared responsibility of getting things and product out the door, right? And it helps us maintain alignment, meaning that different parts of the company are using the same definition of done so that when we publicize we're going live with X, right, on this particular date, and some other part of the organization said, we thought done just meant it was merged into the code base, not that we're ready to release, it's not tested. We have all this friction in the organization. So that's the reason why we want done to be defined. So let me give you an example, right? The goal of your project is to develop 10 new features and deploy them to the users, but you haven't deployed any of them yet. How much of your features have you done? I mean, you're good at math here, right? Right? You've got nothing done, right? The customer hasn't seen anything. You're toiling away in obscurity, right? So you have nothing done. As far as the customer is concerned, nothing has happened. Now, this is usually where a manager or TL or something will pop up and say, look, we've coded and tested 5 of them, so we're 50% done. Well, yeah, but no one knows about your doneness, and no one can act on that, right? So what do the better question would be, when do we expect something, you know, like be really specific, to be deployed and active everywhere in production? Because if you're not in production, your stuff is maybe useful, right? And maybe harmful, depending on what happens. So to create this shared understanding with you guys in the audience, I'm going to have some basic terminology we're going to have to get through. So what is the business value of software engineering? It's delivering desired product outcomes in incremental steps. All right, that's what the value that the engineering gives to the business. Why do we do incremental steps? Right, why not just big bang stuff into production? right? Well, we used to do that in the early days. We found out it didn't go so well, right? Making huge changes all in one shot. That's why we had a lot of what we call the failures of projects. So we want to have incremental steps so we've shorter horizons, right? And if the time horizons is shorter, there's less certainty of going on, right? We also have lower risk because we're changing less in one shot, so we have lower risk in production. We can't just take the system down and say, too bad, let's go back and revisit that. Right? And you get better feedback from your customers. So if you're doing a bunch of incremental steps, you can course correct in the middle and say, well, okay, we thought we were going here, but now the customer wants to go there. So we can course correct. And because we start breaking things down into lots of incremental steps, it's important to know the cadence and delivery of these steps, right? How they all fit together and how we get dates out of these steps. Because it's not just, I'll deliver you something a year from now. Right? It's like, I'm going to deliver you this next month and this the month after, and we have a cadence of delivery. Okay. So software value, the value we're giving to the business is actually materialized, right? We have this thing in the standard about values materializing. When does value materialize for the business from software engineering, right? It only shows up when your customer actually is able to access it. All right, and that means that you have to have the feature available, and it's got to be there to be used. It's got to be usable, and it's got to work correctly, and it's got to work correctly every time. If it's a service, it's got to be there, right? It's got to be reliable. And it's got to be there, it's got to be up. It's got to do the same job over and over again. This is what your customer sees. This is where you put the value in. However, that's a pretty short or limited definition of done, because there is a definition of looking at software value from the engineering side, right? And there, the value comes from your software being configurable. It can do different things without you having to rewrite the code, all right? It's flexible. So when you bring changes in as your markets are evolving or your operations are evolving, your code can accept it gracefully. You don't need major rewrites to do new operations, all right? You're able to fix issues quickly. It doesn't take you 2 months to fix an issue. You can fix it. You're pretty agile in how you fix things. And it evolves. You can evolve quickly. As your business evolves, your software is able to evolve with it as well and keep pace. So what types of improvement do we as software engineers deliver to the business or to production? Well, new features, right? Good one. People are very much into that. What else do we deliver? Yeah, look at this. It's like I primed the audience here. What else do we deliver to production? No. Good stuff. What is the good stuff we deliver? All right. We have to put, I don't know, if you're in a large organization, you need this thing called feature flags. You can't just roll out code, it breaks, and you roll 10 things back. You have flags to turn on functionality. All right. What else do we deliver? Configuration, right? New configuration gets rolled out to enable new ways of doing business. And you should be rolling out some tech debt reduction in the form of refactoring or code depreciation. And what else would we roll out? Yeah, I do get to that. That's a bit forward down the road. But I'm going to say environmental or infrastructure. Right? I gave 2 years of my life to a Linux migration of Ticker Plant, right? So all our machines was moved over to Linux hardware. So we got a huge drop in latency and stuff. So these are the things we deliver. I'm going to say the positive things we deliver. What other types of change do we deliver to production? Someone said it earlier. Yes, broken functionality we deliver to production, right? We also deliver missing functionality. You know, if we missed the deadline and we didn't put the functionality in there. What else? Yeah. I don't know if that shows up in your actual software because the customer sees it working. He doesn't know that all your code is hacked and pasted together, right? So performance issues, what's observable, right? Security issues, right? Big thing these days about software and the safety aspect of things. And we also deliver system unreliability. In other words, the system starts falling over with the changes we're putting in because we don't have a very good code base to work in. So these are the other things we, I say unwittingly deliver to production. We'd rather not do.
It's changed usability in that as well. A lot of flexibility. And it works differently to how it worked before.
Yeah, I think that was. Yeah, that's kind of. Yeah, that's like fixing a bug you put in there. But So these are the kind of, we want to like eliminate the bad changes and put the good changes in, right? That's what make them flow a little more smoothly. But what is in a commitment to deliver change? Right? Someone says, here's what I want done. What do you need to know? I got people here and no one knows, really. A bunch of engineers, product people. You have to know what you're delivering, right? What have you promised? Right? You can't have just some spongy idea of deliver X, and you have no idea really what that entails. So you have to know what you're delivering. And a way of specifying that is with acceptance criteria. And what are acceptance criteria, right? There are a set of conditions that your software must satisfy to be accepted by the user. Right, so, and that's very important, by the user, not by the team doing the change, but by the actual user who's going to use the change, right? And good acceptance criteria should have a few qualities, right? They should be clear, right? Straightforward, easy to understand. They should be concise. They shouldn't have a lot of waffle or like telling a big long story. They should be very precise, and here's what we're going to do, right? Testable, a big one. One I struggle with in the organization is making sure stuff is testable, right? And observable, right? In other words, if I'm getting something to look, I've put some really, really nice templating in here. Yeah, that's not observable to anybody, right? So what's the effect of that? Are we getting better throughput, better time to market? These are the observable effects we should be looking for, all right? And one thing that's, I see a large mistake being made by a lot of people is acceptance criteria describe what you want. Here's what I want to happen. Here's how the operation will work, but not how it should be implemented, right? That's the engineer's job to figure that out, right? And there's processes for figuring, making sure we get that done correctly. But again, acceptance criteria is the what, not the how. So to know what you're delivering and writing acceptance criteria, who writes acceptance criteria?
You just try.
It can be you, if you're, leading this particular effort, or it can be the product owner, all right? It gets shared with the team because you get more input, more consensus, more brain power pushed in on the problem, right? But it's reviewed and validated with the customer. This is the thing we kind of leave out a lot, right? In other words, we have come up with acceptance criteria. What does the customer think of those acceptance criteria? Oh, you've made a mistake. That's not exactly what I want, right? So they get to review it. And I've used the given, when, then style, the gherkin, cucumber, various vegetables they use to describe this style, all right? Where you say, here's my scenario. And I had a scenario where when I was doing this migration, I had test Linux machines and regular production machines doing A/B testing. And it's like I had this thing running every day on bunches of machines, and I would get these huge amount of errors, and it was because the reference machine had gone bad, right? It happens. And I was like, given I have a daily suite of comparison testing between test and reference machines, when a reference machine has a bad environment, it's been built, it's got non-standard software, right? There's various checks we can do to make sure the environment of it. If any of them is bad, then I'm going to replace the reference machine with a machine from a backup list, and I'm going to repeat this check. So this was something I committed to deliver, and it meant all the spurious stuff I was seeing disappeared, and I was looking at clean data to see if I actually had a problem, not problem due to stuff like that reference machine having a disk blow or something like this. So these are how you would do it. All right, so now you know you have something that you need done, but where is the domain of the change you're doing? Because there are various, I'm going to say, categories of change. You say to someone, well, how hard is this problem? I have no idea, right? But we're looking into it, we'll figure it out. This is not a domain problem, this is a priority problem. This is someone just not getting around to it, right? You need to give them a push to get to do it. But we do have simple problems, the nice ones, right? What's a simple problem? It's a known and straightforward solution. You don't really have any external dependencies, and it's pretty low risk. I'm adding some extra category to my computation of a mid-price or something like this. I don't have to talk to a lot of people, so it's simple. And we have complicated changes. Complicated changes have lots of moving parts. Essentially, it's like a lot of simple problems just bunched up together. Need some analysis. There's usually multiple potential right answers, and you just got to find the rightest answer given the trade-offs, the pros and cons. All right, so that's complicated. When we get to difficult problems, they're complex problems. And these complex problems have these characteristics, right? There are lots of unknowns, Bunch of external dependencies. You're not quite sure how to get something done. There's a bunch of coordination needed because they're usually wider spread. And because of that, we have to manage the risk, right? The risk needs a lot of management. There's a lot of coordination goes into it. So this is the sort of domains of where your problems are. And there is a SINFIN framework, it's called up here, which shows you these problems. There's also problems called chaotic. That's when we have a production fire, right? The production has gone down, and that's not engineering, right? That's just us trying to plug the hole or put the fire out. So I'm not going to deal with that today. But these are where your problems can sit. So what's the requirements of scope of your changes, of the project you're in? What is project scope? Anyone know what project scope is? I got to tell you, I'm a little worried here that most people seem to not have any clue on what I think the vital things you need to know what you're delivering, right? Project scope is the complete list of features or deliverables of a project. All right, that's what it is, right? It can also specify what is out of scope. Here's what I'm having, and here's what's definitely you're not getting, okay? And these are deliverables usually created using the requirements or even acceptance criteria for your project. Now, what is the killer of most projects, and especially in the early days, was scope creep, right? Where you expand the list of features of deliverables from those originally agreed. And it's not that you can't be a little flexible and say, I will do something more, but either you give me more time or you take something away, right? The idea of just absorb won't really work, right? That's where we get blown projects. And you know, I know where I am, I look at, here's what was supposed to be done in that quarter, what's on the next quarter, all the stuff we didn't get done in the last quarter is our next quarter's work, right? We're pretty bad at estimating stuff. And requirements should specify what the change are in bounded terms, right? In other words, you don't say, yeah, I'm going to do all equities trading next quarter. It's like, I'm going to trade these particular securities in this particular way. So you're very precise. So the uncertainty goes down. It's always lessening the uncertainty gives you better time estimates. So if you know what you're delivering, what's the next thing you have to know, right? Is, well, when is this stuff going to show up? Right, so it's great. Yeah, you know what I'm asking you for? That's great. And I just walk away, right? That's no good to me. When is this going to be delivered? And this is something else we have a little trouble with, right? When is a change going to be done? And I leave it specifically in quotes because I don't know what that means, right? We're going to talk about that. Well, some of the answers I used to get on this large project was, well, whenever, right? It's kind of in the hands of the God. When I get to it, not sure, right? This, again, is a priority problem, not a time estimation problem. But I would get like, yeah, it's soon, in a while, you know. This is, again, I don't know how to, manage time scales when I get that kind of information. Couple of weeks, month or so, I think that's when we'll get it. How am I supposed to run a project with that kind of information? And it's like, you can't. So I used to always say, can I have an actual date, please? And it's 3 weeks from now. Well, we're going to come in 3 weeks from now. What is the date? I don't understand. And they're like, well, no. 21st of September. Okay, fine. You've given me the date. So when I try and hold you to that date, you're not going to feel too bad about it. But you're going to feel pretty bad if you're not used to being held to account. And, I had a reputation for wanting dates, and that was seen as somewhat aggressive language. Unbelievably so, right? Give me a date is aggressive language when you're last for a project. It's like, that's what bare minimum I need to get my project done, right? Now, most engineers, you think, here we are, I have an actual date. I'm good, right? Plotted on a chart, a Gantt chart. Here's where we're delivering. Cool, what more could I need to know? Well, the problem is most engineers, God bless them, I'm one of them, have misplaced optimism, right, on what it's going to take to get a change done, right? They assume a best case scenario and probably have a bad definition of done. Here's a bug. When is this going to be fixed? Oh, I can knock this out in an hour. Right, but knocking it out in an hour means that I have the repo cloned, I have the editor write up in that piece, and I got the thing to compile, and I believe it worked. I haven't even wrote tests yet. That's a really poor definition of done. But we always assume the best case scenario. You want to please people who are asking us this. I'd rather not I would say a more conservative version of what's going on. And we're going to get into that soon, right? But the question often forgotten is, when will a change start? I've had this bite me a few times where this is a bug in this migration. It's an Endian bug. When's it going to be fixed? How long is it going to take to be fixed? 2 days. Well, 4 days is the next release. I'm good. Next release, I see the bug still there. I go back to the team. Why is the bug still there? You failed to fix it. You didn't test it. Oh, we didn't start it yet. It's going to take 2 days or 3 days, but we have to start. We're going to start it like 2 weeks from now, right? Important information to have. You would think they would just volunteer that information, right? But no, that's not how it works, right? And then depending on your problem type, like we talked about before, is the uncertainty. So you usually have to do more like confidence intervals. It's going to be this kind of time, and I'm 80% sure, because there's so much. It's a complex problem, and there's a lot of stuff I don't even know about yet. So good time estimates. Again, why would we bother giving good time estimates? Isn't it good just to give nice, fluffy stuff we can't be held account to, right? Well, no, because when you have good time estimates, it creates a sort of a trust or a bond, gives you some political capital is what they call it with your customers. So when things do go a little off the rails, they're more forgiving, right? Because you don't do it very often, or you ask them for a favor. I need to push this thing out a week. Is that okay? Well, yeah, right, because you're normally pretty good. How do you give better time estimates? What's the one thing you can do now that you know what it is? Just shout it out. You don't need...
I can only finish this piece. I can identify the first step.
Right, yeah. I think that really means break changes down into smaller pieces, right? Because as you make it smaller and smaller, the uncertainty lessens because the time horizons come in. I mean, I've literally talked to someone about a change that was needed and been told it's 3 weeks. And then when I say, well, just show me the various pieces of this problem, break it down for me. And then to break it down and say, now put the time scale on it, it comes out at 5 weeks, right? So when you break it down, you get less uncertainty. All right. So have specific requirements that we talked about before. So when I'm asking them something, they're pretty clear on what needs to be done. And you've got to embrace what I call empirical reality. I've told the story a few times. Like we use scrums, and I used to be in a team where we had a scrum. And for 3 solid months, we put 24 points of work in the scrum. And we never got above 14 points delivered in a scrum, right, in the 2-week period. So I'm asking them, I don't know, this is 3 months in, why are we putting 24 points on the board again? I know empirically you're only going to get half of this done. And the answer that kind of came out, they didn't really think about it. And then when I caused them to think about it, I said, well, we're aspiring to get this amount of work done. I was like, well, that's really bad for the people looking at you as a black box. You're just like someone that doesn't deliver half the stuff you promise. So again, brace empirical reality, right? And then lean towards the contingency fund. Now, this thing always gets people saying, well, you know, if I say this is something that's 2 weeks, needs 2 weeks, 10 days, a contingency fund in time means I can absorb some extra stuff I don't know about. So 10%, so maybe a day. So I say it takes, 11 days instead of 10 days. Small contingency fund. And this is done in other engineering. If you're getting your house renovated, they'll say it takes, 50K. I need a 5K fund just for stuff I'm not going to know about that we bump into, right? Why don't we have that in our engineering practice as a contingency fund on time? Now, when people start talking about, they say, yeah, if I'm going to say it takes 2 weeks, my contingency fund is 2 more weeks. Like that means you need to go back and look at your scope and requirements and break stuff down. You have no real clue of what you're doing, right? So you sort of a small contingency fund, all right? And then the other thing is, as you are progressing in a project or delivering something, especially if it's complex, as you get further in and timescales and more certainty happen, you know better what's going to happen with the end date. So if your date is here and you're halfway in the project, you're like, that's moved out another 2 weeks. Right? I know that now because I'm halfway through the project. You communicate that back to the people who are waiting on it. All right, you have less uncertainty as you go through it. Right? And if you're delivering bad news, like sometimes it's good news, I'm going to be done a week early. Lots of times it's not going to be. It's going to be a week or so late, right? But if you deliver that news 2 months before, it doesn't have the shock value. If you deliver it the night before, right, people are taken by surprise. So bad news delivered early is better than delivered late, right? Take that and put it away. So are we done? So that's just a few definitions, right? So I can get into an actual talk so we all understand what we're talking about. So I'm going to tell you, right, there was a school of thought, I'm sure you guys are not, you never commit to anything concrete, right, or easily measurable, so you can't be held to account, right? You'd be vague, a lack of preciseness, means you can't be pinned down on anything, all right? That's not about achieving good outcomes, that's about escaping blame of something you're probably figuring is not going to have a favorable outcome, right? So this is not a talk for that. If you're looking for a talk for cover, how to not be pinned down on things, you're in the wrong hole, right? You need to be somewhere else, right? But let's begin now. We're looking for better outcomes. How do we go about that? Well, has anyone ever heard of Maslow's pyramid of needs, human civilization, right? Where the bottom layer is, getting food, killing it, shelter, stuff like this. The next layer is community, like village protection, security with the wall around it. You go up this pyramid and you get to the top of it, and you're writing Shakespearean sonnets and stuff like this, right? And self-actualization. Now, the thing is, this pyramid is a pyramid for a reason. You can't be writing Shakespearean sonnets when you're running through the woods being chased by a bear and you're all very hungry, right? You got more immediate survival concerns. So I thought, there is a similar pyramid for software engineering, right? Where do we have the layers of survival, security, all the way up to we're doing our own Shakespearean sonnets in the code, all right? So this is what I'm going to try and fill over the next, is it hour I have left? Yeah, okay, cool. So, first thing, is the development of this change done? All right, so I have a change. How do I know it's been done? Well, let's say I'll go to some base definition. Is the development done? Have the changes been verified and applied, right? Have we met the acceptance criteria? It's number one. Is it doing what we said it would do? Right, and is it doing it fully versus partially? Sometimes I'm behind, but what I have done is valuable, so I'm going to push that out first. All right. Have we passed all the tests that we have in the validation system, right? Is all the tests that used to work still work? And have we added new testing to catch the changes or the difference in operations we've put in? Right? Have we passed code review? Right? Because the stuff before this means that it's doing that job. It doesn't mean that it's doing it in a sane manner or with safe architectural practices, right? So that's what code review, very important. And have we merged it into a package for production release? So, yeah, it's in the code base. Am I done? That's kind of, I think, the definition used by Scrum a lot, right? I've put it into the repository, right? But is it ready for deployment? Because if it's just sitting in the repository and I don't have a deployment package scheduled, again, the work is not going to materialize its value. And I guess there's this thing about, is the change code complete? Right, I think that's a fiction or a strange way of talking about things because in reality, when we put a change in, we believe it's V1 of code complete, right? But we don't really know that it's code complete. It could be bugs, it could be anything in there, all right? So this is, who uses this as a definition of done? Hands, just a show of hands. You don't have to even shout out. One person? Who uses Scrum or Agile? All right, because that is your definition of done, as far as I'm aware, right? You get it into the code base. Okay, so that's one part of done. And you can say, look, when I'm talking about done, I want to know when it's in a deployed package, right? That's not my definition of done. When I'm doing something, it has to have more legs on it than that. So the next thing I ask, well, is deployment done? All right, are the changes deployed everywhere in production? And what is the pace of deployment? I'll ask people not what the pace of deployment is. Again, I'll ask for a date. When is this going to be deployed? Yeah. You kill that? Sorry, technical issue. All right, when is the code deployed everywhere? And when I ask someone, can I have a date when your code is deployed? They'll go back and then give me the pace of deployment. Well, I got QA, I got beta, I got 3 stages of production. Here, be this date, this. Here's the date it's going to be in production. And that's really the one that's important to me, right? It's important maybe for mitigating risk that we push it out in stages, but really till it's everywhere, it's not really anywhere, okay? And do we have any staggered dependencies? In other words, are there other teams doing stuff that's part of this whole thing working that if their stuff isn't in, ours won't work? Right? I've got to then track them the exact same way and make sure these things come together. So that's like, is my deployment done? And something that plagues me is code freezes, right? There's a general election, there's a holiday, there's something going on, you're freezing the code so that no one's around to trap any hours you might push in, so we don't push hours in. And that makes your timelines go out. You're saying, well, it doesn't affect the functionality of the code, but it affects the delivery of that functionality. Okay, this is a definition of done. All right. You saying you do, guy? Lone guy in the room? Okay. All right, so anyone know what a feature flag is? All right, if you're in a large organization, you will have this, guaranteed, right? If you're in a small startup, this is not something you need till later, right? What is a feature flag? Well, it's a tool we have that we can, at runtime, enable or disable a change that we have made. Okay, and they're kind of circuit breakers in the code. So we can say we added new functionality, our app is going to hell in a handbasket. Okay, turn it off, and now we're good again. We don't have to roll it back. And why do we not just want to roll code back? Well, I don't know how it is in your organization, but when I'm putting a code change in, there's 8 or 10 other groups putting changes in as well. And some of them are maybe critical fixes. And if I mess up the code base and have to roll it back, all those critical fixes get rolled back as well. So that's why we have feature flags, right? And when I say here, circuit breakers for untested code, I don't mean you didn't test it at all. I mean, it's never run in the real world production environment, right? It's not tested there. Even though I know testing in production is seen as and it is a bad thing, but eventually you have to put it into production and just see how it goes, right? So feature flag in it, yes?
Another case for feature flags is for breaking dependencies. You can enable a feature when the dependency is ready. Now, your code's in production waiting for the other dependency rather than to do.
Right. You don't have to synchronize your deployment because you'll use the feature flags to turn stuff on. Good point. All right. So feature flag enablement, you have the same set of questions you have for deployment, right? Deployed code that hasn't been switched on, again, is not useful. You're not showing any value. So our feature flags enabled everywhere in production. So if I've got feature flags, it's not, is it deployed everywhere now? Is it deployed everywhere with the flags turned on? No, what is the pace of that enablement and when will it show up? All right. And then with feature flags, it has this other insidious property of you get whole dead branches of the code that get left in, right? And then when you go to refactor, it becomes a nightmare because people aren't sure whether that thing will ever be turned back or not, right? We'll get into that in a bit, right? I'm going to deal with that later. So software engineering completeness, or the survival pyramid, I'm going to fill in the bottom row of that for you now, all right? So this is what you need in the bottom layer of your code base to be, or in your pyramid to be able to have code survival. So congratulations. If you can do this, you have achieved survival of your code base. You're able to take a change and get it from development into production, right? So great, right? Congratulations, you're a competent coder, all right? So, and lots of people are consumed by that, and we need people that are in that arena, all right? But I have a rationale why that is not enough, right? Same way sitting in a cave eating raw rabbit is not enough for me, right? I want houses and stuff like this. So what's my rationale? Well, survival is not enough because any system where engineering is invested just in rapid feature development or bug fixing, that code over time will devolve into a very brittle system that becomes harder and harder to manage and keep up and running, okay? And as code gets bigger and ages, these problems just, get exponential. All right, so you need to find a balance between feature development and long-term product sustainability. So we have to reverse entropy in the code. All right, so let's go to code health basics. Let's look at a different level of operating on software, right? Software decommissioning, what is it?
Retire features that are no longer needed.
Yeah, right. It's the strategic process, right, of retiring outdated software, right, and infrastructure, right, and usually makes the code more maintainable, easier to work with, easier to put more change, being able to do that, what I say, evolving quicker and fixing problems quicker, right? There's two kind of types I look at least when I've seen code bases, is the first type is code that is never able to be called. There is some function, and when you grep it through the rest of your code base, you find out nothing is calling it. Pretty simple, get rid of it. And I've come across vast swaths of code what I've been in looking around trying to figure out in a new code base, and it turns out that they never called anymore. It's like, why was this left in? I don't know. We want to take a trip down memory lane sometime and see how it used to be done. I had no idea. It's just our laziness. I don't know. All right, but the other type is code that is never accessed with current input. In other words, we used to trade in this way. The exchange used to send information of this particular type, and they've stopped sending it. This is a little more tricky, right? Because you're not quite sure if it might show up again. And imagine you take that code away, and all of a sudden, oh, wow, it started sending it in on the leap year or something like this, right? So we want to monitor usage over a length of time, all right, to make sure we can move these up. But you still should be doing that, especially if you knowingly put in a change to do something new. You know the old one's going away. And that's when you should be doing it, not you look at a piece of code out of nowhere and wonder, wow, I think this is never done anymore. All right, and feature flag removal fits into this, right? A dead branch of code. I see branches of code, and it's like the feature flag was turned on in 2016. And it's been forgotten about, right? Again, not the way to do things. So is your decommissioning done, right? Was there any decommissioning needed in the feature or whatever you committed in your change, right? If we're replacing something, right, we can't just take code out immediately, but have we put something on our backlog, and I don't mean in the pit of the backlog never to be seen again, right? In a strategic part of your backlog where you say, I have decommissioned to come back to in 3 months when this thing is completely ratified and running correctly. All right. Feature flag removal, another thing. All right. We should need to get this stuff out. Eliminating dead branches of the code just keeps your code, I'm going to say, svelte or easy to work with. You don't get into vast branches and find out they're dead. I was working on a piece of code. I thought it was refactoring. I went up. I found out it was on a dead branch. Right. Again, stuff you don't want to do. Right. So that's one part of code health basics. What's another part is software refactoring. All right, what is software refactoring? Yeah. Anyone else? I mean, you guys are all sitting here like you're amazed. I mean, you've never refactored a piece of software? All right. It's a disciplined process, not an ad hoc, a disciplined process of changing the software in a system. Doesn't alter the functionality. Sometimes we add it in when we're altering functionality, right? And it improves the code's maintainability or structure. And sometimes efficiency, but that I think is if you're trying to get latency out, you generally go the other way. You're putting in sort of like bad patterns. But this is what refactoring is, right? And why is refactoring needed? I mean, surely as engineers, we would never put in suboptimal solutions.
Because we're working with a team. Other people do stuff.
Yeah, I think that could be summarized up with this idea of tactical strategic change. Tactical means we're going to do it faster. We're going to trade speed for quality. All right. And why would we do something like that? Well, normally it's due to time challenges, right? There's refactoring time needed. It's not budgeted. We didn't have adequate time to research if this is a safe way of refactoring the code. And what also happens is if we don't have code properly tested, you're afraid to refactor a piece of code because you're not sure you won't inadvertently, in a brittle system, break something 100 miles away in the code base, right? And what is the gatekeeper for this stuff is code reviews, right? If you're poor code reviewing, or I review your code, you review mine, and everything's good to go, right? Then we get bad things happening, right? Code review is supposed to be the last line of defense of getting bad stuff into your system. But sometimes it happens just because new ways of doing things comes along, and you find that these different pieces should all now be refactored into one spot. Okay. At the bottom there, very important, I do believe that if you don't refactor or do code health, the deprecating of code, over time, your system will head inevitably for a rewrite. And that's why people go, this system is a lost cause, it's legacy, I need to do a rewrite. And management hates to hear that because we have such a bad track record, because we don't get it done properly, right? No, and I'll tell you why a little later. But is the refactoring done, right? Have we got refactoring as part of what we've done? Have we introduced tech debt, right? Is there any refactoring that's needed due to this, right? We have recurring duplicated patterns that people have been adding in the code. They just haven't known there's something beside it that does nearly exactly the same thing, right? Do we have low readability and maintainable code, right? Got a lot of code smells, pointers being passed around a lot, raw pointers with allocated storage on them, right? Is it overcomplicated logic that's showing up? Right? Are we using standard components? Are we rolling our own components? Like, you know, we have our own version of an optional because we didn't get to C+17 way back then. They didn't have it, right? Are we able to, do we need to do any refactoring in that case? We have paradigm changes. We're doing things just in a different way, right? Things should be done different. Do we have technical depreciation of the code? So code ages. Even the best written code will age, right? As new technology comes along, more effective ways of doing things, it's going to show its age over time. All right, so these are all things that you would need to do refactoring for, or why you would do refactoring. All right, so let's move on to technical debt, another area of code health, right? What is technical debt? Anyone? No, there's lots of old stuff does good stuff, good fit for purpose. Yes, exactly, right? Technical debt is the cost of reworking some short-term fix that we did to get something in. All right, so we did something quickly, not maybe the best way, so we could get stuff in. All right, I just boil it down to unnecessary complexity in the code. Right? I'm a simple guy. I don't have large definitions. And that's why if someone comes to me, here's a really nifty, complicated way of doing something that could be done much simpler, that is to me is technical debt. Right? You're showing how clever you are. Someone's going to sit down for a week trying to figuring that out when they come around the next time. I also have cases where I've seen a class that's a template. And I say, well, why is this a template? I don't see you using it with anything except one type. Well, in the future, someone might want to use another type. And I go, well, in the future, that person can templatize the code. Right? So stop prematurely optimizing your code because you can't see into the future very well. Right? The people in the future are much better at it. Right? So why do we get technical debt? All of these things here, right? The first couple is tight deadlines, firefighting, right? We're kind of forced to do stuff. Other thing is, as I said, cleverness, premature optimization. I was in a code base one time and I was looking at a piece of code that was really serpentine. And I said, why are we doing this? Well, it gets us from 48,000 to 50,000 trades a second. I said, but the system is bounded with other I/O to about 2,500 a second. So why are you making the code so much complicated for something that's not actually useful? Right? Again, premature optimization of going after stuff. Other thing is lack of skills, right? Or a poor culture. Your group just always did stuff kind of gnarly.
What was necessity was to become tradition that we realized.
Yeah, it's just become the way it's been done. It's kind of that insidious thing. Do you have a comment, question?
Some of these attempts, does it eventually?
All right, well, he's doing now. I'm going to talk about the end of the list. So organic growth and poor documentation of features is another thing. All right, so in other words, the code just grows over time. It was never really planned to go this particular way. People have just jammed stuff on, right? And it becomes like a really misshaping mass, right? And poor documentation, right? We don't know why stuff was done and we've no trail back to why it was done that way. Some coder just had it in his head and put it. So this is why we would have technical debt in it, right? And all this happens over a span of time. It's not like Sunday a code base is great and Monday there's a bunch of technical debt in it, right? It's over time, like as code base is evolving, that this thing makes its way in.
Or people would start a workaround that they never needed. But because we didn't have the easy way to do it, then we have discovered people got very creative, not asking for the better way. We had to get better at documentation.
Right. Okay.
So the debt was theirs caused by us.
Yeah, it's still debt, right? From 1,000 feet up. So there's a guy Napton, and I really like what he said. I think he's a software TL or something. But he said there's nothing so permanent, I would say, in software engineering as a temporary decision, right? Because we don't go back and revisit these decisions. We make them and say, just for now we're going to do it this way. You're never coming back to it, right? So what are the categories of technical debt? Is there any good technical debt? Is it all bad?
makes a decision. It's just a difference between what we speak now and what we did when we wrote the code in the first place.
And I'm going to disagree a bit with you there. I'm going to say there is good technical debt. Oh, it is? Well, then good. I agree with you. All right. So we have two categories of technical debt. I'm going to call intentional tech debt, right, where we say, look, I've got to get something to market quick. So I am going to take a substandard solution to make that happen. Or there's a fire in production. I hack my way to getting it correct. So that's taken on, but you take it on consciously. I know I'm doing not the good solution, right? But it also has to be paired with some way of mitigating that. In other words, when you're saying, here's what I'm doing to get by it, there's a JIRA item, something on your backlog that says, and this is where I'm going to undo that technical debt. The payment terms are set up now. All right. The other type of technical debt is what I call unintentional. Right? It's just non-strategic. We're just essentially doing a poor job. You just put the bad solution in, and there's no plan to mitigate it because you're either unaware or your code reviewers are unaware that it's a sub-solution, or you've just got into a culture that's okay to do it this way. Okay? And the same guy, Napton, said that for projects he does, right, a project is not done until you go back and adjust whatever it was you took on as technical debt. And everybody agrees, so we share this around, that this is how we define done. So it's not just delivering the feature, it's also taking the tech debt out you may have accumulated with putting that in for a particular time, okay? Who uses that as a version of their done? No one? I think this is a great version. All right, well, now you know about it. Maybe you try and use it, right? So again, how do you track tech debt? They always say if you can't track it, you don't know if it's there, you don't know if it's growing, it's less. Well, I say you make a list. It's a pretty easy list. Just what's the effort on this? Here's the tech debt. What's the effort? Medium, small, medium, large. You can be fairly fuzzy. And what's the severity of these things? How bad is it affecting our time to market? How bad is it trying to get stuff done, even simple changes in the code base because of this tech debt? All right, and be intentional. All right, add to a list. I had a group. I was doing a code review, and they said, yeah, 3 engineers looked at this and said, this is kind of odd way of doing it. Not really the way you should be doing it. But it was near the end of the quarter, and the TL said, it's okay for now. Let's just put it in because it actually works, even though it's a very strange way of doing it. And I pleaded with them to put an item on their backlog to go and address this problem later on. No, we'll do it next quarter. Believe me, that they didn't do it next quarter, all right? So again, you have to be willing to say, look, it's not that I'm doing a bad job, it's that I'm being responsible and splitting the work in 2, the tactical fix, the strategic remediation afterwards, all right? And you've got to keep this thing visible. It's no good, like I said, consigning it to the bottom of your JIRA stuff where you say, like, that's where stuff we don't want to deal with goes to die, right? And have tech debt sprints. I used to have be on a team, and I would say once a quarter we had a tech debt sprint.
What was the reluctance to put it on the backlog?
What's that?
What was the problem with putting it on the backlog? Why wasn't it added? What was the reluctance?
Because you're admitting to putting in a suboptimal solution, right? That's what it came down to, right? We don't do substandard work here. It's not substandard. You're just trading speed for quality, right? And you got to advocate or champions. Someone has to be someone that pushes this. If there's no one in the group that cares about it, this stuff just doesn't get addressed, right? And someone was saying, well, management doesn't care about refactoring and depreciation. They absolutely do when you parade the business risk across. Because I've personally done this. I've got the managers in and said, here is why you have an 8-week rollout for a simple problem. Right, and when you show what the problems are, and with data, I back it up with, I don't just say, this is what I think. Here's your hard data. They go, wow, how do we address that? And now you can start getting something done, all right? And here I talk about maintenance load. It just means that the developers are not actually doing code health or adding or bug fixes, just trying to keep the damn thing up and running, right? And that's like you're treading water about here, but you're not able to swim to shore, right? So you're going to eventually drown. All right, so is your tech debt done, right? And so if you have a list, a few places have, you have a list of tech debt, people don't want to go on that list, so to try and prevent it, right? So how do you prevent tech debt going on the list? Well, you have proper timeline planning with a contingency fund, right? You have code review guidelines to make sure dodgy stuff doesn't get in there. And if people complain, you're going after me. No, look, the guidelines say this. So that's why you should be doing it. Right, having coding standards, another thing that's kind of tricky. I think it's like the great thing about standards is there's a lot of them to pick from. And if you don't like any of them, you can create a new one, right? So that's the problem with standards, but you should have some agreed upon standard, all right? And design reviews. In other words, you don't just, hey, I want this done. You just run off and come back 2 weeks later. Here it is. And they go, wow, what a bad design, right? And we have to backtrack. And we have design reviews before you go with some prototyping, but like it's not where we go way down the track and do a lot of wasted work. Right, and then like I say, if you track it, people don't want to go on the list. If you go, yeah, that's a suboptimal thing, I gotta put you on the list. Well, hang on. I'm going to take another half day, and now it's not going to go on the list. Right, so you have that going on, and training of all the above is also needed. Right, we need training. I don't think we do much training in this. It's like all about the latest C++ and what's the later hyper spanner we can use inside of the language. Right. So what about testing? Is testing done? You say, well, who would put code in without testing it? I mean, really? I mean, who would do such a thing? Well, I have hard data showing lots of people do it, right? All right. So are all your testing pillars about it? Well, there's 3 testing pillars, right? You've got the unit testing, happy, unhappy path, close to the developer. You run it, you get your feedbacks, seconds later. Integration testing. You bring your app up and you have all fake dependency apps that are talking, usually Python's, things that are talking to it. And you can see the stuff working in operation. Is that testing happening? And then you have end-to-end testing where it's in the actual system, usually using, like if you're a trading system, fake traders. If you're a ticker plant, it's going to be a fake exchange. But right, you're able to test how the actual system handles the data. How am I doing for time? Holy moly. Okay. So we want to maintain quality through testing. That's how you maintain quality from your customer's perspective, right? You're doing the right thing and you're not breaking features. Okay. So is testing done? And when we find problems in the functionality, are we leveraging that experience, right? Are we creating tests? The one thing that kills me is that we get a production bug, someone fixes that bug and puts it in without a test. So next time it gets broken, we go, oh, and I think the first time, look, testing coverage is a tricky thing. You might miss out on testing coverage and say, well, look, it's forgivable. I didn't know that would happen, right? But if you say, look, the second time it happens in production and you go, we had this bug 2 months before. How did it come in again? Well, we didn't put tests in. You need to be, I don't know, hung up on a wall and, I don't know, flagellated or something, right? You need to be given some disincentive. Right, so you create tests so that you never get that problem again, right? And make sure you've added adequate test coverage. Try scenarios. Scenarios is, if you're looking at legacy code base and someone hasn't set the scenarios out, now you got to look at the code branching. And, even though various branching paths would never occur naturally, you still have to test them all. So have test coverage, identify corner cases, right? Where are the things where you're likely to have a problem, right? Where you have nothing of something, where you overflow something, these kind of things. And then you got to automate the testing, right? All this manual testing, great, right? It means someone has to be there to run the test to spot the problem. You should have automatic testing happen, right? And they're, again, hooked into alarms so that as this testing is going on, end-to-end testing happens, there's a problem, a flare is sent up, right? You don't have to be looking at the screen. So again, my rationale was survival in your code base is not enough. You're going to get a brittle code base, right? Because if you just do engineering and bug fixes and hacking your way to success, over time, you have a code base that's hard to work with and you need to rewrite it, right? So I'm going to fill in now a second level or layer on a pyramid. Here's the second layer of software engineering needs, I'm going to say, right? So you're doing this stuff for code health, right? And once you're doing these kind of things, and great. Now you have a sustainable code base, one that will last into the future, right? You're actually now an engineer. So, congratulations, you're now doing engineering. You're not just coding anymore. All right, great. So, anyone know what's going to be further up this pyramid? Right, we're going to be expanding our awareness of things. And what you find is above this layer, there's a real change in emphasis. All right, this here is You know, below it is kind of, I guess, what we're more familiar with, right? But when you go above this here, there's a big change of emphasis. And it goes from are we done to are we prepared, right? And when someone asks you, are we prepared? They're using the are you prepared, right? They're like not really including themselves. And again, probably not, right? Why is that? What's the next level of engineering awareness we should be striving for, right? So I'm going to say that system reliability and resiliency. We always talk about just reliability. I think we have to talk about resiliency as well because we can't be perfectly reliable. So what is system reliability? Well, it's that the system performs whatever it's supposed to do correctly with no failures or downtime. That's perfect reliability, and we don't have it. So we need to say, well, we also need some resiliency in a system. What does that mean? What is the difference between reliability and resiliency? Anyone?
Reliability doesn't break. Resiliency is what you do when it does.
Correct. So it's the ability of a system to degrade gracefully in times of stress or functional problems, right? And not just like core dump or go offline, right? So your system degrades, you're getting stuff slower, but you're still up. People are still getting the service. All right, so you can strive for perfection with the reliability, but in the real world, you're going to have resiliency as well. So why do we care? I mean, if it's up, it's up. If it's not, just wait till it is. Why do we care? It's not working today, but there's a release coming out sometime, you know, in a wee while. Why do we care about this? Well, you know, if you don't care about this, what is going to impact? It's going to impact on your user trust. They're going to start thinking you're just, you know, you can never rely on this thing, right? Your business continuity gets affected. People using your product, they're like, yeah, we can't do business. This thing goes down half the time, right? And other thing, if you're in a big, you know, I'm in Bloomberg, we get brand reputation. If we have a big problem, it's going to hit the press, right? So we want to keep that reputation intact, right? So let's talk about system reliability. So it's more to do with how healthy is your overall system. What is the aggregate health of your system, not just the code, right? Are changes impacting your system's health? And as we're getting changes in, are we rolling them back regularly? Are we bringing the system down? Are we causing problems in the system? And can you catch these problems before your client does? Well, how could anyone do that, right? That's kind of looking into the future. How could you possibly catch a problem before it shows up? Well, let me amaze you, right? Do you have health monitoring of your system, right? How healthy is your system right now? Okay, do we have operational metrics on it, right? We have the LETS ones, right, which is latency, how long does it take something to be done, throughput, how much stuff can get done in like how long do I wait even if it starts getting more and more? You can have like regular latency and high throughput. Saturation, how close to the edge are you going, right? Is your queue starting to saturate? You're going to start dropping data. If you're using circular buffers and in some kind, you know, which we do. And hours, right? How many hours are you having? And by the way, an hour is not your system saying they're like an hour. I mean, I illustrate it by an ATM program. Of $50 in my account, and I ask for 100. It's saying you can't get $100. That's not an hour. That's the system performing perfectly. Right? If I give them the $100, it's an hour. Right? So how many hours are my system not performing the way it's supposed to? All right. And any system will have other metrics, just you know, that applies to itself. Right. So you have these things being monitoring, but how do you use system health monitoring? How do you predict problems that are going to show up? Well, you have alarms on it, right? Latency starting to spike, alarm, boom, get people looking at it. Queues are starting to saturate, right? These kind of things are happening, right? You want to avoid eyes and glass. I mean, I had a thing where someone put a print statement in a hot loop of the code, all right? And it was missed in code review, went into production. It was actually missed in latency. It's just when I looked at the code, it said, there is a print statement in the hot loop. They went to look at the dashboards and seen the latency went up 300% in that particular spot, right? There should be an alarm on there. It shouldn't need someone to figure out we need to go look for it. So again, alarms, and that gets you to figure out, is there imminent outages coming along? The other thing someone mentioned earlier, you can monitor trends over time. I can see my saturation climbing. I can see my CPU being used, all right? So as you're going up this hill, you say, well, you know, a year from now, we're going to go over the cliff. our system's not operational, so you can do capacity planning. What about production support? So this thing is now out there. Is it supported? Someone just put a Rust program out and we're all a C++ shop, right? Is it properly supported? Have we used new technology that's not well integrated in the company, right? Is it supported by operations or by the developers, right? If it's supported by developers, it's not so great, right? You woke up at 3 o'clock in the morning. Do you have distributed triage? In other words, you know, it's not one guy who knows how to do this. Literally, we had a problem in a system I was in, and the guy was on a beach in Mexico, and we had to wait the week for him to come back because no one knew the code. And again, it was really tough code to figure out, right? So is it widely known and supported? So have we got proper production support? What about improvement planning, right? What is improvement planning? It's identifying areas of risk that need fixing or optimization. I can see this part of the system is having trouble. This is where I'm going to target efforts or focus on it, right? It's usually more broad scale as far as functionality changes goes. And because of that, you usually have a lot of stages, iterations. It's a complicated problem lots of the times. And we have to figure out how to mitigate the risk to production. What are the predicted timelines? What's the effort going to be for this, right? It's usually a mid-level, about a year, I'm going to say, a year or less. So mid-level timelines, but it's non-trivial releases, and it's usually got a lot of groups involved. So we got many external dependencies, and if you haven't worked on a project with lots of external dependencies, it's a nightmare to keep them all rolling in the one, right? I mean, how hard could it be to keep 30 teams in lockstep, right? Let me tell you, I've done it. It's really, really hard and very frustrating and time-consuming. So that's another thing. Let's go to another thing you should be thinking about, as I said, as you're going up in this awareness. What about architectural design? What I call strategic local re-engineering. Pieces that need redoing, not a rewrite of your system. A rewrite means I've given up, right? Whatever I've been doing or whatever my predecessors have been doing, I've given up. But you can say, this piece, if I re-engineer it, it's going to give me an extra 5 years of life in this system, right? Usually complex changes in the architecture, how we're doing things. We're moving to the cloud. Vision, we're going to manage future performance. We're going to get new machines in. We have to cluster or shard the data differently. Right? Where are we going to target the system for the most benefit? These are things that you're going to look for, right, when you're looking at the architecture of the system. Sometimes called staff engineer type stuff, right? Are we leveraging existing technologies or introducing new ones? And I see a mistake people make where they say, look, let's use every new technology, new database, new communication, new everything in this small piece of the system. It's like the old database is doing fine, right? So why bring that extra risk in? At least put it in phases. So now I'm going to look even further out. So even further out, right, what is the strategic vision? Am I starting to think strategically about the product and where we're going with this, right? These are decisions that are long-term, multi-year decisions, influencing the direction that we're going and how we're going to get there, right? And it's beyond just technical details. The business usually has to start getting involved here, right? Because we're dealing with things like shifts in how we do business, technology shifts. We got AI coming in, right? You got, Rust coming in as something people are wanting to use. How do we future-proof a product, right? How are we ready in the future, right? And we're usually weighing trade-offs, right, for a number of different solutions. We're picking what we feel is the best. So strategic vision, what is it? How do we know when we're doing something strategic? Well, usually the more people involved in it, right, the more strategic of what we're doing. There's more people brought in. If the time span for these decisions go over years, again, longer the time, more strategic. All right, and we're looking for longer term outcomes. And because of that, it's important to do proper analysis of where you're going, because once you get on one of these large strategic path changes, it's hard to come off it. All right, it's a real bear to come off it. I decided to go to the cloud. I decided I don't want to go to the cloud, I want to go someplace else. If you're halfway through that, it's a huge problem. You generally are like, you just can't get off the track. You're on this train. You got to make it work. So my rationale is, why was sustainability not enough? Actually, I think I might have skipped that slide. But my argument was sustainability is maintaining the current state of your code, right? But your code does not live in a vacuum. It's got to run in a whole ecosystem, and you've got to start thinking about that whole ecosystem, right? And that means that efforts are needed to reduce manual toil, automated testing, stuff like this. Capacity planning, meaning for I'm looking to the future so that we don't just run into a wall without knowing anything. And having general observability within your system. And you also need further efforts to figure out where you're going and how you want to get there when you're looking further into the future. So I'm going to start filling in now the next layer of this pyramid, right? So here we have strategic vision, architectural redesigns, and having a proper observable system to find capacity, to be able to find problems before they hit the customer. And once you do this, well, you have system reliability, right? Now, again, I want to congratulate you if you're doing this kind of thing. Is this what occupies your day? Well, great. You're a competent systems engineer now. You're not just down in one part of the code. You're working on a broader level of awareness. All right. And companies need that, even if some of them think they don't. All right. Again, I'm going to say, but that's not even enough, right? I'm still trying to work my way up this pyramid. Why is having this reliability and resiliency and the whole system just working nicely? Like, what more could there be to software engineering life, right? Well, no, your engineering must align with the business needs. We have this thing called the business side of things, right? How we get the money to pay our wages and stuff. So again, we were talking about that business value. All right, engineering must align with business, right? So efforts are needed here to communicate clearly and bi-directionally, meaning the business goes to us, but we tell the business stuff as well, that needs are being met and adapted to. So for that, we need roadmaps, right? What is a roadmap meeting? All right, it's a formal meeting. It's not just a loose aggregation of people talking around the water cooler, right? It's a formal meeting where a group assembles to decide the current progress, how it's been made, and the direction of where we're going with some project or some deliverable we've agreed to, right? And the reason we have this is to ensure everybody is on the same page and we're all striving collaboratively towards a shared objective, and we all share in the responsibility of it getting there, all right? So we have ownership. Okay. So what is a roadmap meeting? Who's in a roadmap meeting? It's not just like I say, a random members of team. You got to have certain roles fulfilled in this meeting. Again, these are high-level strategic decisions. You have to have a product owner, right? That's who's going to create the roadmap, right, and present the strategic goals. It can be you. Lots of times it won't be. You need a business analyst or a proxy, essentially for the client, who explains how the user is going to engage with this new stuff. Here's what we are looking for on the business side. Right? Engineering can't just deliver what it wants to deliver. It's got to deliver what the business actually needs. You have to have, I'm going to say, department or section heads there, because they're going to explain any roadblocks they see with where we're going, right? What the effort and timelines are going to be. And they're also going to flag risky shortcuts, right? We might, if you're trying to do this here, we found that's bad in the past. Do we make a strategic decision to do it right, or do we say tactically we're going to do it wrong and fix it later? And you need an executive stakeholder here. You need a head of department. You need someone there who can make the executive decision, and then it sticks. Right? Someone who's in authority, one of the like your VPs or something like this, right? And then if what you should have, and I've worked with these guys, product delivery specialists, they're really good in that you give them all that information, they give you the Gantt charts, and they show you, here's where this project is coming out a year and a half from now. And when someone says, hey, we have a delay here, this whole thing comes and says, we've just moved out another week in 2026. So it gives you good timeline planning. That's their speciality. So they should be in there because this is more of a formal thing we're doing. So what goes on in these roadmap meetings? Because I used to run one for this migration I was doing. Well, you review the current landscape, which means that you're looking at the progress that was being made since the last time we did it, and any roadblocks and current problems we are having. And that's why you need also the heads of departments and stuff there, because you can go, we have a blocking problem, let's say on the database. Something's wrong, or we need some enhancement to the database. It's a big red thing on your thing, and I go, so this is actually a blocker for us going, and I just want to let the database head explain what's going on there, right? Very public, a lot of high-powered people, they're encouraged to get the problems out of the way, right? So that's what we have. We set strategic direction, so where we're going, how we're getting there, and we usually have a lot of buy-in, including the executive decision maker. And we prioritize and allocate the resources. When are we doing things? Who's assigned? All right. And once we have assigned, the thing that should be coming out of this thing is the action plan or an update to the action plan. And what that has on it is the actionable items with clear criteria of what success means and dates attached. So review the long-term timelines and make sure we're still on board, right? Future planning, someone said that out there, right? We're planning for the future. Are we prepared for things like software stability, right? Security vulnerabilities, system scalability, our system, where we need to scale it. Who's thinking about that for the future? And are you ready for things like new technical opportunities that have shown up? All right, the big thing these days is AI. Are you figuring out a way to pull that in? Everybody seems to be, right? Have you got new business opportunities opening up? Are you ready to go after them? Right, and where I am, we have regulations being dropped. The EU will drop regulations. The SEC will drop regulations. You can't just say, we're not ready for that. Right, we can't, some radical trading stuff you're not supposed to allow anymore? Yeah, we just can't get that to market. You know, you have to be able to take these on. This is when I say you're operating on the level of how's the whole product doing with the business, right? And how do you stay competitive, right? If some small startup comes up and starts because it's got a really small code base that's new, starts doing things, and you say, well, how do I stay competitive? So again, my rationale was the overall reliability of our system is not enough because that's just looking at the software. You need to align with your business. And efforts are needed to make that happen, all right? Because engineering and business, as much as we might want to not accept the fact, we have to collaborate and compromise, right? And effectively communicate. The business has to understand the limitations we're under, and we have to understand what the business is looking to do. So the very top of the mountain here, the apex of the pyramid, is to do with aligning the business needs with engineering goals and making sure both sides understand. All right. And when you have system and business alignment achieved, well, that's great. What do you think you are now? Where have you been? No, but close. Right. You're now a visionary. Somehow you've brought heaven on earth in software engineering, right? The business and system are aligned, which means that you're able to pivot, you understand the needs, and you're able to make strides in what you're doing instead of small broken steps that you have to backtrack, all right? So it's like we have a great organization with a healthy business engineering dynamic. How am I doing for time? 15? Cool. All right, so this is the software engineering pyramid. As you see, if you don't have the things on the bottom, I don't think you probably have the things above it, right? Or if you do, they're going to be very just dictatorially driven, right? They're not driven by data. Again, if you're interested in features and stuff like this is kind of like, you're at the coding stage. Usually when you're earlier in your career, all right? And you work up that pyramid as you go later and later, and hopefully as you progress, if you don't go down the management track, that is, right? So software engineering, what level are you operating at, right? I think most people are engineers or associated with engineering. And I'm going to build this list from the bottom up the same way I do the pyramid. So is your day-to-day feature implementation of bug fixes? And if you are, take a look at that lower level of the pyramid and make sure all of that is happening. All right. And then maybe aspire to what's going on above it. Maybe you should be aspiring to more about code health, taking a bigger interest in what's going on outside of the narrow features you're implementing. All right, so you're looking at the code base health and the sustainability and the ease of the people who are doing the feature implementation to keep making those who are having really tough times with very serpentine or very chaotic code bases, right? Are you thinking about system aggregate health, right? Are you thinking of how does the whole system perform on the hardware, right? With the customer interaction, how is that doing? And then at the end, like I say, if you're at the, if you're doing feature implementation, you're probably not worried about the direction of your company, your market competitiveness or something. That's something that as you go up, right, you're talking to people with, I guess, more and more power. So it usually correlates with how long you're in the game. So software engineering, when are you done? I don't know if I've confused you or enlightened you, right? It's like, wow, I was drinking from a fire hose, right? When are you actually done? Well, what's the type of doneness we're talking about? We're just putting it into a code base or we're getting into production? So we have to be specific on the scope, right? In other words, what are we delivering and what is the chunking of that delivery? Well, what is the time associated with that? Now I know what I'm actually delivering and the pieces I'm going to deliver, right? What's the dates and the milestone dates that are on that? So people can know where it's coming and know when I go off track. If I'm in the middle, supposed to be here on week 5, and I'm actually here, I know I have to adjust what's going on. So you got a better idea and earlier warning to your users. Intentional tech debt. In other words, you're taking on stuff strategically, not just letting it pile up, and you have remediation built into your process. And again, communicating clearly to your stakeholders that, right, here's the progress we have made, and here's the thing that's holding us up. And maybe you want to get out and help us with that. So in recap, when are you done in software engineering? It's when your feature, your bug fix, whatever your change is running smoothly and engaged everywhere in production. That's what done means. It's well supported by the team. In other words, you don't need the guy to come back from Mexico, all right? The tech debt is decreasing or not increasing in your code base. You're putting effort in to keep the chaoticness and the complication out of your code base. You've got structured, maintainable code because of that. And when you have structured, maintainable code, you have happy developers and you retain your engineers better, which, by the way, is something management will listen to, all right, because it's a hassle and expensive getting new engineers. Your users are now happy. When your users are happy, the business is happy, all right? So everybody is on the one page, and we're now poised to meet future challenges. We're thinking ahead. We're not just living in the now, as much as that is a philosophy, all right? So, and finally, I'm going to summarize it up as this presentation is well and truly done. Thank you, everybody.